The article referencing a potential shift in home wiring toward two-wire receptacles and baseboard outlets may be the one authored by Mike Holt. This concept explores the possible benefits of using a two-wire electrical system combined with baseboard-mounted outlets. These benefits could include greater flexibility in placing outlets around a room, potentially lower costs associated with installation, and enhancements in overall safety. For example, a homeowner could easily reposition outlets to suit changing furniture layouts or technological needs without requiring extensive rewiring. Furthermore, the simplified wiring configuration of a two-wire system compared to the now standard three-wire system could lead to cost savings during the initial construction phase. However, it is crucial to understand that this is not a currently accepted or regulated standard within the electrical industry. There are no existing electrical codes or regulations that specifically address or approve the use of two-wire systems with baseboard outlets in residential buildings. Therefore, the widespread adoption of this approach in the immediate future is improbable. Electrical codes such as those developed by the National Electrical Code, or NEC, are designed to ensure the safety and reliability of electrical installations. These codes mandate the use of grounding conductors and other safety measures that are not inherently present in a basic two-wire system. The absence of a grounding conductor can increase the risk of electrical shock and fire hazards under certain fault conditions. In a standard three-wire system, the grounding conductor provides a low-impedance path for fault current to flow back to the source, allowing a circuit breaker or fuse to trip and quickly de-energize the circuit in the event of a ground fault. This rapid disconnection minimizes the duration of the fault and reduces the potential for damage or injury. Without a grounding conductor, a ground fault may not be immediately detected, leading to a prolonged period of exposure to hazardous voltage levels. This is particularly concerning in areas where moisture is present or where conductive surfaces are within reach, as these conditions increase the likelihood of electrical shock. The NEC extensively covers the requirements for grounding and bonding in electrical systems, emphasizing the importance of a properly installed and maintained grounding system. These requirements are detailed in Articles 250.1 through 250.198 of the NEC, which address various aspects of grounding, including the sizing of grounding conductors, the methods of grounding different types of equipment, and the bonding of metallic components to ensure electrical continuity. For example, NEC Table 250.122 specifies the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device in the circuit. This table ensures that the grounding conductor is capable of safely carrying the maximum fault current that could occur in the event of a ground fault. Additionally, NEC Section 250.104 outlines the requirements for bonding metal water piping systems and other metallic components that could become energized due to a fault. This bonding helps to create a low impedance path for fault current and minimizes the potential for voltage differences between conductive surfaces. Given the importance of grounding and bonding in ensuring electrical safety, it is unlikely that electrical codes will be revised in the near future to permit the widespread use of two-wire systems without equivalent safety measures. While the concept of two-wire systems with baseboard outlets may offer certain advantages in terms of flexibility and cost, these advantages must be carefully weighed against the potential risks to safety. Any proposed alternative to the standard three-wire system would need to demonstrate an equivalent level of safety and reliability before it could be considered for adoption in mainstream electrical codes. Furthermore, the development of new technologies and safety devices could potentially mitigate the risks associated with two-wire systems. For example, ground fault circuit interrupters, or GFCIs, are devices that can detect small imbalances in current between the hot and neutral conductors and quickly trip the circuit to prevent electrical shock. The use of GFCIs in conjunction with two-wire receptacles could provide a measure of protection against ground faults, but it would not eliminate the need for a dedicated grounding conductor. In addition to GFCIs, arc fault circuit interrupters, or SIs, are another type of protective device that can detect dangerous arcing faults in electrical wiring. SIs are designed to trip the circuit when they detect the characteristic signatures of an arc fault, which can be a precursor to a fire. The use of a size in conjunction with two-wire systems could help to reduce the risk of fire caused by arcing faults. However, it is important to note that GFCIs and a size are not a substitute for a properly installed grounding system. These devices provide additional layers of protection, but they do not address all of the potential hazards associated with electrical faults. In conclusion, while the concept of two-wire receptacles and baseboard outlets may be an interesting topic of discussion, it is not currently a viable alternative to the standard three-wire electrical system. The absence of established codes and regulations, as well as the potential safety risks associated with two-wire systems, make it unlikely that this approach will become a widespread reality in the near future. The electrical industry places a high priority on safety and reliability, and any proposed changes to electrical codes must be thoroughly evaluated to ensure that they do not compromise these fundamental principles. The NEC is continuously updated to reflect the latest advancements in technology and safety practices, and any future consideration of two-wire systems would need to be based on solid evidence of their safety and reliability. This evidence would need to include extensive testing and analysis to demonstrate that two-wire systems can provide an equivalent level of protection against electrical shock and fire hazards as the standard three-wire system. Ultimately, the decision of whether to adopt two-wire systems with baseboard outlets will depend on a careful balancing of the potential benefits and risks. The electrical industry must weigh the potential advantages of increased flexibility and reduced installation costs against the potential disadvantages of increased safety risks and the absence of established codes and regulations. Only through a thorough and objective evaluation can the industry determine whether this concept is truly a viable option for the future of home wiring. And also remember that electrical work should be performed by qualified electricians who are familiar with the relevant codes and regulations. This helps to ensure that electrical installations are safe and reliable and minimize the risk of electrical hazards. The potential reduction in installation costs with a two-wire system is only realized if there is no trade-off for safety, as safety is paramount. The future of home wiring may involve incorporating smart home technologies with standard three-wire installations. These technologies could help with energy management and efficiency. For example, smart outlets can monitor energy usage and automatically turn off devices when they are not in use. Smart circuit breakers can provide real-time monitoring of electrical circuits and alert homeowners to potential problems. These technologies could provide benefits to homeowners without compromising safety. One could consider future home wiring to involve the use of renewable energy sources, such as solar panels and wind turbines. These renewable energy sources can reduce the reliance on fossil fuels and lower energy costs. The NEC contains specific requirements for the installation of renewable energy systems, and these requirements must be followed to ensure safety and reliability. The electrical system needs to be properly sized and installed to accommodate the output of the renewable energy source. In addition, the system needs to be connected to the grid in a safe and reliable manner. One important aspect of electrical safety is the use of surge protection devices, or SPDs. SPDs are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes, power outages, or other events. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. SPD work by diverting the excess voltage to ground, preventing it from reaching the protected equipment. The NEC requires the use of SPD in certain applications, such as in dwelling units and in industrial facilities. It is important to choose the right SPD for the specific application and to install it properly. And the selection of the correct conductor size for wiring is of utmost importance. The conductor size must be adequate to carry the maximum current that the circuit is expected to draw. If the conductor size is too small, it can overheat and cause a fire. The NEC contains tables that specify the allowable ampacities of different types of conductors based on their size, insulation type, and installation method. These tables must be consulted when selecting the appropriate conductor size for a particular circuit. Furthermore, electrical installations should be inspected by a qualified electrical inspector to ensure that they comply with the applicable codes and regulations. Electrical inspections help to identify potential safety hazards and ensure that electrical systems are installed correctly. The electrical inspectors are trained to identify code violations and to provide guidance on how to correct them. Regular electrical inspections can help to prevent electrical fires and other hazards. The continued development of new materials and technologies will likely lead to further advancements in electrical safety and efficiency. Researchers are constantly working to develop new types of conductors, insulation materials, and protective devices that can improve the performance and safety of electrical systems. One area of research is the development of superconducting materials, which can conduct electricity with virtually no resistance. Superconducting materials could potentially revolutionize the way electricity is transmitted and distributed, leading to significant energy savings. Another area of research is the development of new types of insulation materials that are more resistant to heat, moisture, and chemicals. These materials could help to improve the reliability and safety of electrical wiring in harsh environments. The future of home wiring is likely to involve a combination of traditional wiring methods and new technologies. While the concept of two-wire receptacles and baseboard outlets may not be a viable option in the near future, other innovations may emerge that can improve the safety, efficiency, and flexibility of home electrical systems. It is important to stay informed about the latest developments in electrical technology and to consult with qualified electricians when making decisions about electrical installations. By following these guidelines, homeowners can help to ensure that their homes are safe and energy efficient. The grounding system is essential for electrical safety because it provides a low impedance path for fault current to return to the source. This path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and to energize the circuit in the event of a ground fault. Without a properly installed grounding system, a ground fault could result in a dangerous voltage buildup on metal parts of electrical equipment, which could pose a shock hazard. The NEC specifies detailed requirements for grounding systems, including the size and type of grounding conductors, the methods of connecting grounding electrodes, and the bonding of metal parts to ensure electrical continuity. These requirements are designed to minimize the risk of electrical shock and fire hazards. Ground fault circuit interrupters, or GFCIs, are devices that can detect small imbalances in current between the hot and neutral conductors. This imbalance indicates that some of the current is leaking to ground, which could be a sign of a ground fault. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the power and preventing electrical shock. GFCIs are required in many locations where there is a risk of moisture, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are devices that can detect dangerous arcing faults in electrical wiring. Arcing faults can occur when wires become loose, damaged, or corroded, creating a high-resistance connection that generates heat and sparks. These sparks can ignite nearby combustible materials and cause a fire. FSIs are designed to trip the circuit when they detect the characteristic signatures of an arcing fault, preventing a fire from starting. FSIs are required in many locations, such as bedrooms and living rooms, to protect against the risk of fire caused by arcing faults in electrical wiring. Surge protective devices, or SPDs, are devices that protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other disturbances on the electrical grid. These surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. SPD work by diverting the excess voltage to ground, preventing it from reaching the protected equipment. SPD are available in various types and sizes, and it is important to choose the right SPD for the specific application. The NEC contains requirements for the installation of SPD to ensure that they are properly grounded and connected to the electrical system. Electrical inspections are an important part of ensuring the safety and reliability of electrical installations. Electrical inspectors are trained to identify code violations and to provide guidance on how to correct them. Regular electrical inspections can help to prevent electrical fires and other hazards. The NEC requires electrical inspections for new installations and for major alterations to existing installations. In addition, many local jurisdictions require periodic electrical inspections for rental properties and for commercial buildings. Electrical codes are constantly evolving to reflect the latest advancements in technology and safety practices. The NEC is updated every 3 years to incorporate new requirements and to revise existing requirements based on field experience and research. It is important for electricians and other electrical professionals to stay up to date on the latest electrical codes to ensure that their work complies with the applicable standards. There are many resources available to help electricians and other electrical professionals stay informed about electrical codes, including training courses, seminars, and publications. In conclusion, electrical safety is a critical aspect of home ownership and building management. By following the electrical codes and by taking the necessary precautions, homeowners and building managers can help to prevent electrical fires, electrical shocks, and other hazards. It is important to consult with qualified electricians and electrical inspectors to ensure that electrical installations are safe and reliable. The potential for innovation in electrical systems is always present.